So now it's time to pre-process our image data. And to do that, I'm going to use weighted batch preprocessing script, or WBPP. But before we do that, we need to set up this cosmetic correction script, or cosmetic correction process, because we'll reference this while we use WBPP. And before we can use this cosmetic correction process, we have to first generate a master dark frame. So let's do that first. We will create a master dark frame. I use the process image integration. I need to add my master dark files by clicking add. Browse to where you have your master dark frames saved, which I have here. And because I was taking 10-minute light frames, I want to use a corresponding 10-minute dark frame as well. And so I think I have 30 of them. I will load them all. The rest of the settings here are already determined for me because I've saved this as a master dark integration process icon. But just to go through here, for image integration, I'm using the average method, no normalization. I weight all images equally, and I use the scale estimator of MAD, which isn't, I don't think it's even used. Because I have 30 images, I'm able to use the linear fit clipping algorithm. But if you are wondering which algorithm is best for you, you can read through this pop-up that appears when you hover over rejection algorithm. And it's mostly informed by the number of images that you have. Of course, I don't want to see my rejection maps. You can choose to do that. I don't want to see that. And then because I'm choosing linear fit clipping, I'm using these values as a part of that process. So that's it. I will hit go, and we will pause the video while it generates this, which is not too long. Okay, so it finished generating the master dark frame, and so I will give it a name, master dark 600 seconds, and I will immediately save that file as an XSIF file type. That's the default file naming or file type for PixInsight, and I'll call it that, and then I'll save it to that processing folder, which I've done already, so I won't overwrite that in this case, but I will save it. And then this is what a master frame looks like, master dark frame looks like. This is very typical of what you would expect to see. So now that we have our master dark, now we can go back into cosmetic correction and set up that process. So let's choose that master dark that we just created. I will choose an output directory, although I don't think the script, the WBPP script, utilizes that because there's a different file path where I'll save it, but I will set it up in any case. I want it to be under processing, registered lights, rather cosmetic correction lights. I will enable hot pixel threshold, and we'll adjust these settings in a moment. Auto detect is another means to cosmetically correct your images. I use hot sigma at a sigma value of 3. And then I do have a defect list. You may or may not have taken the time to generate this one. This is a tedious process of mapping every single bad pixel or suspect pixel in your sensor. And it takes a while to do it, but once you've done it, you can save it and then use that over and over again going forward. So I have that saved here, and I will load that. And so there you can see there's a couple columns, pixels, etc. that are defined here that are I've said each and every time I process this, please go out there and correct these. Now, there's one thing that we still haven't set is the hot pixel threshold settings. What sigma value should we be using? And the only way you can do that is just by feel, by looking at an image. Now, I don't have a calibrated image yet, so I have to do this on a raw image and estimate the settings for this, and then once WBPP runs, it will use these settings. So I'm just going to randomly select any one of my raw frames so that I can look at it. I'll just choose a red frame here, and I'll open it, and I'll screen stretch it so I can see some things. I'll quick generate a preview just to speed things up here, because I really only need to look at a portion of the image. And hopefully before I click the preview mode, you can see that there are pixels, little tiny dots that are suspect that can be cleaned up. And so those are the types of things that I'm looking to get rid of using the cosmetic correction script, or process rather. And so now if I click generate preview mode, hopefully the majority of those will now be removed because the auto detect feature is turned on right now, and the use defect list is turned on right now. If I blink this, if I turn this off, hopefully you'll see some pixels come back. For example, I can't zoom in using this, but if you hopefully you can see this on the screen. There's one here, there's one here. When I turn it back on, you can see that they go away. Okay, but now there's one here that doesn't appear to be disappearing. I hopefully will be able to catch that with the hot pixels threshold settings. And so that's the next step, is I grab the sigma bar slider here and I start bringing it down. And as I'm bringing it down, it's starting to find pixels that it's going to reject. Right now there's 261 that it will replace at this sigma level. But rather than look at the numbers, I just look at the image and bring that slider down until I think it's too far, and then I go back up just a little bit. And you'll see it right away that when you go too far, which is right about there, it started adding actual dots, which is not good. So I will go back up, try to get above that threshold, maybe there. And again, it's a kind of a feel thing to determine where that needs to be. And so I'm happy with that. I will close the preview mode. I will clear out. I can close this image. I will clear out the images because that'll be loaded by WBPP. And I'm going to save this as an instance on my desktop so that those settings that we just created will be preserved. And now you'll see process 47 I will call as we load WBPP. So let's do that. We'll go into script, batch processing, weighted batch pre-processing. And this is where all the magic happens. This is the automated part that I mentioned. That given the same data, in general, one person to the next will end up with the similar results, and that's why this can be automated. So you can see from my previous session, all the data's in there. So I'm going to reset this, clear all the file lists, reload all settings. I'm going to say all to factory default so you can start from the scratch. So I'll do that. And now we'll go through each and all the settings so that you can see how this script works. Right now you see I don't have any files listed under bias, darks, flats, lights. And so we'll load those right now. All right, so there are different ways that you can add the files. If you want to force PixInsight to treat a certain file as a certain file type, you can use these buttons down here where it says add bias, add darks, add flats, add lights, and it will ignore the FITS header information and add it as what you've indicated. Now, I want to leverage the power of the FITS header, which specifies each of the file types, and it saves a lot of time. So I will just click Add Files and let PixInsight do all the work. And you'll see here, this is where I have all my raw data saved. It is hundreds of files here, maybe not hundreds, but lots of files. And it has the light frames, has the flats, and it has the bias frames in it all mixed up. And rather than me take the time to sort and add those manually one by one, you can use PixInsight to read the FITS header to load those. So I will just select all of them and let it figure it out. And you can see that in terms of lights, it found my blue frames, my green frames, my red frames, and it also found one test frame that I took that was a luminance. I'm going to delete that because I'm not going to use that. So I have my RGB frames. I have all my flats that I took that same night, and so I took, I think, 21 of each filter. The bias frames are all have been loaded under as bias frames, and the only last thing that I didn't have in that folder was the master dark that we just created. So I'm going to go out and add that one. Okay, and because I'm using a master dark in this case, I want to make sure to tell it that. So I'm going to check this box over here, use master dark, and it grays this out for the dark frames. For the master bias and master flat, however, I'm going to have PixInsight, this WBPP process, create those first masters, and then it'll use those to calibrate the light frames. All right, so what are the other settings that we can go through here? Bias, because I reset the tool, I'm fine with the default setting here to do an average, and then rejection algorithm can be auto, which it'll choose based on the number of images we have. There's nothing to set here for dark because we already have our dark master. For flat frames, again, combination average, and let it choose what the best rejection algorithm is. Based on these settings, I'm fine with that. And then for light frames, you could choose to calibrate them only and then stop at that point, where it wouldn't do any weighting, it wouldn't do any registration or any integration. I want to do more than just calibrate, so I will leave that unchecked. I will do cosmetic correction. We just set that up. And so I'm going to select process 47, which is what we just set up before. And I want to generate the subframe weights. This is a very beneficial feature that has been added to this script, where it'll go and evaluate each and every image to determine how good it is. And how good it is measured by three main things. Before I show you that, I do want to compute all the weights after registration or before. I don't know what the benefit of that is. I'm going to leave it unchecked, but I do want to use the best frame as the reference frame for registration. And so how do I want to weight those? What's the best way? What's the criteria that we use to call one frame better than another? And there's some presets here. There's nebula, galaxy, and cluster. And this kind of makes sense. For nebulas, you can see the weighting factors. They have signal noise ratio as a factor of 20, whereas eccentricity and full width, half maximum, or a measure of your sharpness of the image are weighted less. And that makes sense because nebula, you want to capture the faint nebulosity. And may not be so concerned with the star sharpness and crispness of the image over the signal noise ratio. For galaxies, you can see that it's fairly equally weighted across those three criteria. And then for clusters, you can see that the signal to noise ratio is a slightly lower than sharpness and eccentricity, because with a cluster you really want to get those fine details in the center of the cluster, And to do that, you want to take the best frames and prioritize those, have more weight those higher than the signal to noise ratio. For this image, because this is a galaxy or a bunch of galaxies, I'm going to choose the galaxy setting. And once you've chosen that, you can X out of that. So that's the weighting parameters. And then registration, I'm not going to generate drizzle data. I don't want to do that. But I do want to just verify that the registration parameters are correct. There's usually not much to set in here because the defaults are usually good. So yeah, I'm just going to go with the auto. And I am not going to integrate these images. I mentioned before that I want to do that manually after having inspected the images. So I'm going to uncheck image integration. I have to choose an output directory, which I'm going to save in my registered lights frames. And then just quick look at the rest of these features here. So I'm not using one-shot color or DSLR camera, so color filter array doesn't apply. These other settings I do want to keep. I don't really care to see my rejection maps. Some people like to see those. In this case, I'm not really concerned about that. I do want to save the process log in case something happens, and so I will save that. And then save frame groups on exit. This is an important feature. If you recall, when I first loaded this tool, it still had all my settings from the previous time that I did this. And that's the feature, that's the box that you check so that it does that. If you exit this process and without that checked, you'll lose all this information and have to reload everything. So it's a little bit of a time saver if you have to come back and repeat this process. So all right, so with that, we have everything loaded. I have all my files there. We can run the diagnostics to see if there's any concerns or issues. Now here it says master bias will be used to calibrate the flat frames. And that's because there's no corresponding dark at that same duration to match those flats. And so I'm totally okay with that. That's what I want it to do. It's not a big deal. But other than that, for the red, green, blue flats, it's going to use that bias frame instead. So I am ready to go. I'm going to hit run, and then we will come back and show you the result. Okay, it has finished, so I'm going to exit out of this script. Yes, I'm sure. And let's just take a quick look using the blink process at the resulting images that it created. So I'm going to use blink. I'm going to load my registered images that it created. I'll just load the blue for now. And change it to about 0.2 seconds and let it scroll through them. And if you can look here that it's done a very good job at aligning the images. And I just like to check the corners to make sure things aren't bouncing around too much. It is possible in the corners that things aren't matched as well in the corners, but maybe very well matched in the center. But it looks like this has done just a fine job at matching. And you can see some of the frames have a black bar here. That's because that image had to be shifted a little bit more in that direction than some of the others. And you'll even see there's some cosmic rays on some of the individual frames. When we go to align those will get canceled out because they only appear in one frame and they're in different spots. And so when you take the average of these, those will get canceled out. Those outliers will get thrown out through the pixel rejection. All right, so this looks like it did a fine job. I am happy with that. And I'm going to go ahead with that. Now you can look at the red and the green yourself. I did that ahead of time, and they look fine. So I'm going to keep going. So let's close out the blink tool. And now, since we've done, let me just pull up our process diagram here again. So as far as pre-processing, we've created our masters, calibration images, darks, flats, bias. We use that to calibrate the data. Then we cosmetically corrected the data and we then aligned all the images to each other. And so now they are ready to be combined or stacked into master red, master green, and master blue, which is what we'll do next. So again, with my icons that I have here, I have one that's already set up called light image integration. I will go through the settings, but if you have these icons, it's a time saver so that you don't have to set these up each and every time. So I have to load the registered images that we just created. So here's the registered blue. So the settings, I use average, additive with scaling. Now fits keyword, I'm not going to use subframe selector weight keyword. That's a different keyword. Instead, I'm going to use the weighting that WBPP assigned. And I always forget what that keyword is, so I have to go look it up. So one of the quick ways you can do that is open up one of these frames that it generated for us and look in the fits header, and you'll see down here WBPP weight is the keyword that it uses. So I'm just going to copy that. I can close fits header, I can close this file, and instead put that keyword there. And so when it goes through and it averages these and combines these images, those with a higher weight will be weighted heavier than the others, and that's the whole point. You can see the selections that I've chosen here that are checked. Pixel rejection, because I only have 7 images, the method that they recommend is percentile clipping. If I had more than 10, then I would probably use a different algorithm, but for now I'll use percentile clipping. I want to see the rejection maps in this case as I combine them. I'll leave the settings here for pixel rejection, and we'll see how that goes. I'm going to try it without large scale pixel rejection. I didn't see any major star trails or anything through the blue, but we'll see how this goes. So let's click process. And generally this goes fairly quick, which is why I still do it as a manual process rather than have WBPP do it. And so you can see here's the stuff that it rejected on the high side. This is the stuff that it rejected on the low side based on that criteria. And this is the stacked image, which looks great. There doesn't seem to be any issues with this. And so I will call that master B, and then immediately save this image, save as an XISF image in my processing folder under integrated master lights. And you can see I've already done that, so I won't do it again, but that's where I would store it. And then now you have to clear this out and do it again for red and green. So again, you just load the reds, select them. It gets faster now because I'm just going to leverage all the same settings and see how it goes. So there's the rejection high map, rejection low map. Looks all right. And then the final stacked red image. And it looks to be a little bit of star trail down here, but I don't think I'm going to do anything with that. It's in the corner, and it's not too obvious. So I think I'm just going to leave that alone. The rest of the image looks just fine, I believe. So I'm going to run with that. Again, rename that right away to master R, and then I would save it. Then last but not least, clear out again, add your green files, hit go, and let it do its thing. So that looks all right. Same thing with the rejection low map, and then the final green stacked image, which doesn't appear to have any issues that are obvious. So I'm going to go with that. Call it master G. And then again, save that. I've already done that, so I'll skip that for now, but save the images. So these are the 3 master images that are critical for you to save. And if you ever want to start processing this over again, maybe you go down processing and you just don't like the way things are going, you can always come back to these 3 files and start over again. You don't have to repeat everything that we've done up to this point. All that pre-processing is done and complete, and if you save these files, you can always use this as your starting point going forward. All right, so we have completed the pre-processing steps that I've laid out in the beginning. We've gone through each and every one of these, and now we are finally time and ready to go on to post-processing.